Good day, Harold Lucas Pagadwan, BS Ed Science 2. Basic concept of electrochemistry. What is electrochemistry?
Electrochemistry is defined as the branch of chemistry that examines the phenomena resulting from combined chemical and electrical effects. Chemical transformation, occurring owing to the external applied electrical current or leading to the generation of electrical current, is studied in electrochemistry.
Basic concept of electrochemistry.
Electrochemical cell. An electrochemical cell typically consists of two electronic conductors, also called electrodes, and ionic conductors, called electrolyte. The electron conductor used to link the electrode is often a metal wire, such as a copper wiring. Type of cell. Electrolytic process. Reaction in which chemical changes occur on the passage of an electrical current. Electrolytic cells are driven by an external source of electrical energy, a flow of electron-derived non-spontaneous delta G greater than 0 is called redox reaction. Another type of cell is galvanic or voltaic process. Chemical reaction that result in the production of electrical energy. Galvanic cell convert chemical potential energy into electrical energy. The energy conversion is achieved by spontaneous delta G is less than 0 redox reaction producing a flow of electrons. Galvanic or voltaic cell. The operation of galvanic or voltaic cell is opposite to the an electrolytic cell. In galvanic cell, electrical energy is produced by a chemical redox reaction instead of chemical reaction being produced by electricity. The classic example of a redox reaction for a galvanic cell is the reaction between aqueous solution of zinc Cn and copper Cu. The structure. In this cell, the zinc is oxidized and the copper is reduced. Initially, they produce a flow of electrons across a wire connected to the two separate electrode solutions. But as the zinc solutions become positively charged from losing electrons and the copper solution becomes negatively charged from gaining them, the flow stops. No more negatively charged electrons want to flow toward the negatively charged copper solution. Galvanic cell salt bridge. To solve this problem and to produce a continuous flow of electrons, which means a source of electricity, the electrode solution must remain electrical neutral. This can be done with a salt bridge. The salt bridge is usually a vanish-shaped tube filled with the concentrated salt solution. The solution in this tube provides a way for ions to travel between two electrode solutions so that they can remain electrically neutral in charge. This enables the continuous flow of electrons. Electrolytic cells. Electrolysis is used to drive an oxidation, reduction, reaction, and direction in which does not occur spontaneously. The concept of revising the direction of spontaneous reaction in a galvanic cell through the input of electricity is at the heart of the idea of electrolysis. Electrolytic cells, like galvanic cells, are composed of two half cells. One is reduction half cell to another is oxidation half cell. Though the direction of electron flow in electrolytic cells may be revised from the direction of spontaneous electron flow in galvanic cells. The definition of both cathodes and anodes remain the same. Reduction takes place at the cathode and oxidation occurs at the anode. When comparing a galvanic cell to its electrolytic counterpart, occurs on the right-hand half cell because the direction of both half reactions has been reversed. The sign. But the magnitude of the cell potential has been reversed. Take note that the copper is spontaneously flattened on the copper cathode and the galvanic cell, whereas requires a voltage greater than 0.78 volts from the battery to plate iron on each cathode and electrolytic cell. Anode and cathode. The electrodes at which electrons are lost is known as the anode, and the one at which electrons are gained is that cathode. At the anode, oxidation or loss of electrons is the process which occurs at the anode. Negative ions from the electrolyte are discharged if they are halide ions such as I negative, Br negative, and Cl negative. SO4 42 negative and NO3 negative ions are not discharged. Instead, OH and negative ions from water are discharged and O2 gas is produced. At the cathode, reduction or gain of electrons occurs at the cathode. Positive ions from the electrolytes are discharged if they are H plus ions or ions less reactive metals, such as Cu 2 plus, Pb 2 plus, or Ag plus. Positive ions of reactive metals such as Na plus, K plus, and Ca2 plus are not discharged in the presence of water. Instead, H plus ions from water are discharged and H2 gas is produced. Inert and a reactive electrode. Inert electrodes do not react with the product produced or dissolved in the electrolyte. Carbon and platinum are examples of inert electrodes, while reactive electrodes can react or dissolve in the electrolyte. Copper, silver, and mercury are examples of reactive electrodes. Working and counter electrodes. The electrode at which the reaction of interest occurs is called the working electrode. The electrode at which the other coupled reaction occurred is the counter electrode. At the third, electrodes, called the reference electrodes, may be used also. Reaction half cell and overall. At each electrode, an electrochemical reaction occurs. This reaction is called a half cell reaction. Since there are two electrodes and a typical cell at which reaction occurs, the overall chemical reaction of the cell is given by combining the two individual half cell reactions. Oxidation. involve the loss of an electron, involve the transfer of electrons from the species to the electrode. R is equals to O plus Ne. Reduction involve the gain of an electron, involves the transfer of electrons from the electrode to the species. O plus Ne is equal to R.